Let's talk about solving nonlinear systems of equations. So in a nonlinear system, you're going to have at least one of your equations be an equation that graphs something that's not a line. So for example, maybe you've got a circle and you're seeing where does that intercept with a line, or maybe you've got a parabola and an ellipse, but you've got at least one equation that is a nonlinear equation. So let's take a look at this one. So notice I have an x squared in my first equation and my y is not squared, which means that this is going to be a parabola. And in my second equation here, neither the x nor the y are squared. This is going to be the graph of a linear equation. So maybe we're looking at something like this. Here's a parabola, and then I've got a line, and we're looking for the 2 points where these graphs cross. Maybe we're looking for only 1 point where they cross, so that means our line would be tangent to the parabola, and it might look something like this, barely brushing at just a single point. Or maybe they don't even cross at all, and you've got something that looks like this. Then there would be no solutions at all. So we're going to go ahead and find the points of intersection, if there even are any. We have two options. You could solve by substitution, or you could solve by elimination. When you're working with nonlinear systems, elimination can be a little bit tricky depending on what you have going on. Remember that when you eliminate, you need all of one of the variables to go away. So sometimes if you have multiple of the same variable, like I do in my first equation, I have an x squared and an x, it can be a little bit tricky to make them all go away. So substitution generally tends to be the method that we lean towards when we're solving nonlinear systems. So let's go ahead and solve with substitution. I'm going to call our first equation equation number 1 and the second one equation 2. To substitute, we need to make sure that one of our variables is completely isolated, and then I'm going to replace it in the other equation. I think it's easiest to solve for either x or y in the second equation. So I either want x alone here or I want y alone. But keep in mind that once you solve, you're going to then replace that variable in the other equation. So if I solve for x, I'm then going to take whatever I have on this right-hand side and substitute it in for x in the other equation. But the annoying thing is there's actually two x's, so I would need to substitute it in two separate places. I don't really want to do that. So instead, let me go ahead and solve for y, and then when I substitute, I only need to place it into one position in that other equation. To solve for y, I'll just subtract my x from both sides, and I find that y is 4 minus x. So now I can take this value of y, go ahead and replace it in the one position that it's in the first equation. So I then have x squared plus x minus the entire y, which is 4 minus x. And that all equals -1. Now my equation is all in terms of a single variable, so I can solve. I'll start by distributing that negative, and then I will simplify. To solve a quadratic, generally we want 0 on one side, so I'll go ahead and add my 1 over. And I am able to factor this quadratic because the two factors that have a product of -3 and a sum of +2 are -1 and 3. Since my leading coefficient is 1, I can jump straight to x minus 1 and x plus 3. My product is 0, so x would either equal 1 or x would equal -3. So I have two x values. What I'm going to do is find the y values that correspond with each of these x values. I can pick any equation that has both x and y in it to go back and substitute, but the easiest one to me would be this equation right here. So let me go ahead and take my x equals 1 and plug it back in for that x value to find the corresponding y value. So my y would equal 4 minus 1, which is 3, meaning that one of my solutions is 1, 3. Plugging in that second x value of -3, I have y is 4 minus a -3, which becomes 4 plus 3 because we have that double negative. So y would be 7, giving me my second solution of -3, 7. So this tells me that my parabola and my line cross at 2 separate points. Those points are 1, 3 and -3, 7. So those are the solution to my nonlinear system. And that is it. Thanks for watching, and I'll see you next time. Bye.